Hi, today's lesson continues our study of equations. In this lesson, we will look at radical equations, absolute value equations, and rational equations. Radical equations. This is the radical sign. It denotes the square root. Were I to put a 3 here, that would denote the cube root, and so on. So equations involving these symbols are called radical equations. Solve. Square root of x is equal to 7. So we're looking for a number x whose square root is 7. The easiest way to solve this equation is to square both sides. So square root of x squared is equal to 7 square. So the square root of x squared would just give me x. That's the meaning of square root of x. It's that number when squared gives me x. So x is 49. And we know that. Let's check. What is the square root of 49? It is 7. Does 49 have any other square root? For instance, minus 7. No, it doesn't. Root of 49 is not equal to minus 7. It is only equal to 7. Please remember that. Second example. 3 times root x is equal to 12. So let me first isolate root x. So I'll divide both sides by 3. So root x will equal 12 by 3 equal to 4. Now I can square both sides and I'll get x is equal to 16. Again, let's check by putting it back in the original equation. 3 times root 16 is equal to 3 times 4. Root 16 is only 4, which is 12. It checks. Root of x plus 4 is equal to 2. Again, I need to isolate root of x. So I'll subtract 4 from both sides. So I get root of x is equal to 2 minus 4. That is, root of x is equal to minus 2. So the square root of a number is turning out to be negative, but that's not allowed. In this case, you have to be aware that this cannot happen. A common mistake would be to square both sides, and you would get root of x squared minus 2 square. So you'd get x equal to 4. And you'd think you've got the answer. But that's not correct. Because this equation has no solution. Let's plug in the answer you got and see that it doesn't work. So if I plug in 4, I'll get root of 4 plus 4. But root of 4 is only 2. So I get 2 plus 4, which is 6. Which is not equal to 2, which is on the right hand side. So 4 clearly isn't the answer. So remember, when you get the square root of something equal to a negative number, then you've reached an impasse. There isn't going to be any solution. Find all solutions to root of x plus 2 equal to x. Here they've given me values, so I'll just plug in values and check. Let me plug in minus 1, which is choice A. So the left hand side and the right hand side. If they match with any of the values, then we have a solution. We plug in choice A. The left hand side becomes minus 1, root of minus 1 plus 2, which is root of 1, which is 1. And the right hand side becomes minus 1. They do not match. So A is out. What about B? Plug in 1. Root of 1 plus 2. Which is root 3, which isn't going to be 1, which is the right hand side. Plug in C. Root of 2 plus 2, which is root 4, which is 2. And the right hand side is also 2. So 2 is one solution. So I can eliminate choice E, which does not have 2 as a solution. E is out. But I need to check choice D, which has minus 1 and 2. But we've already eliminated minus 1. Minus 1 was not a solution. We eliminated in choice A. So, the only solution is 2. And the answer is C. Again, Were you to square both sides and solve this equation, you would get a quadratic equation, and that would have two roots. It would have the roots minus 1 and 2. And you would make the mistake of thinking both those are answers to this question. But they are not. They are answers to the quadratic you would have got when you had squared. To check whether those answers are valid, you would have to plug them in to this equation. But since they had given me solutions, I just plugged in directly. I didn't bother squaring both sides and solving. If 2 raised to minus 2x minus 2 raised to minus x minus 6 is equal to 0, what is the value of 2 raised to x? Complicated looking question. 2 raised to minus 2x is actually 2 raised to minus x the whole squared. Just apply the laws of exponents and you can multiply these powers. This becomes 2 raised to minus x times 2, which is 2 raised to minus 2x. So this is correct. So now I rewrite my equation as 2 raised to minus x the whole squared minus 2 raised to minus x minus 6 equal to 0. So now here's the big step. If I treat this as y, then I have the same y here. So this turns out to be a quadratic. This turns out to be the quadratic y square minus y minus 6 equal to 0. So by making the substitution y equal to 2 raised to minus x, I've reduced this complicated equation to a quadratic. And surely I can solve a quadratic equation. I just need to factor it. So this becomes y minus 3 into y plus 2 equal to 0. Because I need factors of minus 6 that add to minus 1. Those factors are minus 3 times 2. Minus 3 plus 2 is minus 1. So the sum and product method works. Therefore, I get y equal to 3 or I get y equal to minus 2 as my solutions. The product of two factors is 0. So at least one of the factors must be 0. So either y minus 3 is 0 or y plus 2 is 0, which leads to y is 3 or y is minus 2. That's all standard stuff in solving quadratics. So what are my two solutions? These are my two solutions for y. But y is 2 raised to minus x. So 2 raised to minus x is 3 or 2 raised to minus x is minus 2. So 2 raised to minus x is 3. The question is, what is the value of 2 raised to x? So 2 raised to minus x is nothing but 1 over 2 raised to x. So 1 over 2 raised to x is 3. Therefore, 2 raised to x must be 1 over 3. That's one solution. How about this? Here, 1 over 2 raised to x is minus 2. So, 2 raised to x is minus 1 over 2. So, those are our two solutions. Our two solutions are, the values of 2 raised to x are either minus half or 1/3. If n is equal to 6 and 8 times 2 raised to m is equal to 4 raised to n minus 6, then m is equal to, so let me just write the equation. 8 times 2 raised to m is equal to 4 raised to n minus 6. And they've given me n is 6. So let me plug that in immediately. So I get 8 times 2 raised to m is equal to 4 raised to 6 minus 6. Which is 4 raised to 0. Anything raised to 0 is equal to 1. So this is equal to 1. So I'm given 8 times 2 raised to m is equal to 1. So what is m? Well, that's easy enough. 2 raised to m becomes 1/8. So I need to write it as a power of 2 so that I can compare exponents. So I can write this as 1 over 2 cube. I need to bring it to the numerator. So I write it as 2 raised to minus 3. 1 over 2 raised to 3 becomes 2 raised to minus 3. The exponent changes sign if you move it from the denominator to the numerator. That's the definition of a negative exponent. So now the bases are the same, 2, so I can compare the exponents and I get m is equal to minus 3. That's my answer, B. Let's move on to absolute value equations. Let's recall what the absolute value symbol meant. So the absolute value symbol meant the following. If I took the absolute value of minus 3, it was 3. And if I took the absolute value of 3, it was also 3. So it was basically, if you plot the number on a number line, for instance minus 3, then the absolute value gives its distance from 0. So any number, its distance from 0 on the number line is its absolute value. So absolute value of minus 4.7 would be 4.7. Absolute value of 0.36 would be 0.36. Simply plot on the number line and figure out its distance from 0. Solve for x. Absolute value of x is equal to 2. So what are we looking for? We're looking for numbers x whose distance from 0 is 2. So clearly, which are the numbers on the number line whose distance from 0 is 2? Well, one number is 2. Its distance is clearly 2. And minus 2 also has a distance 2. So x must be 2 or x must be minus 2. These are the two numbers whose absolute value is 2. The safest thing is to plug it in. So I plug in 2 and I get 2. I plug in minus 2 and I get 2 because both these numbers have distance 2 from 0. Solve for x. Absolute value of x plus 3 is 5. So here we are told that the distance of x plus 3 from 0 is 5. So what are the two numbers whose distance from 0 is 5? I know that absolute value of 5 is 5. And I know that absolute value of minus 5 is 5. And there's no other answer. These are the two numbers whose distance from 0 is 5. So therefore, whatever I have within the absolute value sign must be either 5 or minus 5. Because that's the only way the distance is going to work out to 5. So I can conclude that x plus 3 must be 5. That's this. Or x plus 3 must be minus 5. That's this. These are the only two values that are going to work. So now I have two linear equations. I can solve them. This gives me x equal to 2. This gives me x equal to minus 8. And these should be my two solutions. Let's plug them in to be safe. So I plug in 2. I get 2 plus 3, which is absolute value of 5, which is 5. So it works. I plug in minus 8. So I get minus 8 plus 3, which is absolute value of minus 5, which is also 5. So it also works. The equation is satisfied by both values. So the answers are 2 and minus 8. Absolute value of 3x minus 6 is equal to 1. So what are the two numbers whose absolute value is 1? I know that absolute value of 1 is 1 and I know that absolute value of minus 1 is 1. So what I have within the absolute value sign should either equal 1 or should equal minus 1. So I have my two equations. 3x minus 6 should equal 1 or 3x minus 6 should equal minus 1. Let's solve both. 3x should equal 7. I first isolate the term in x by adding 6 to both sides. Then I divide, so I get x is 7 by 3. On this side, I again isolate the term in x by adding 6. So I get minus 1 plus 6, that's 5. So x is 5 by 3. So the two solutions are 7 by 3 and 5 by 3. We should always plug it in quickly to check that we're right. Plugging in 7 by 3, I get 3 into 7 by 3 minus 6. 3 and 3 can be cancelled, so I get 7 minus 6, which is absolute value of 1, which is 1, so it works. Here it's 3 into 5 by 3 minus 6, which is 5 minus 6, which is absolute value of minus 1, which is 1, also works. So the two solutions are 7 by 3 and 5 by 3. Absolute value of 4 minus 2x is equal to 2. Again, what are the two numbers whose absolute value is 2, either 2 or minus 2. So we know the game now. 4 minus 2x should equal 2, or 4 minus 2x should equal minus 2. Solve these two equations. So I get minus 2x is equal to 2 minus 4, that's minus 2. I divide both sides by minus 2, I get x is equal to 1. Here I get minus 2x is equal to minus 2 minus 4, that's minus 6. So I get x is equal to 3. Again, quickly plug in both values to verify your answers. Never choose an answer without quickly plugging in. Absolute value of 1 plus 9x is equal to minus 5. So which are the two numbers whose absolute value is minus 5? Well, of course, absolute value of 5, so minus 5, 5 equal to 5. Hold it, there's a problem here. The right hand side is minus 5 and the left hand side is an absolute value. The absolute value can never be negative. It has to be 0 or more because the distance from 0 has to be either 0 or a positive number. So I can never get an absolute value of any expression equaling minus 5. Not possible. So there are no solutions. No matter what value of x I take, the absolute value of 1 plus 9x is never going to be a negative number. If absolute value of 2x minus 4 is 2 and x minus 3 square is 4, find x. I can either solve 2x minus 4 is equal to 2, get my two solutions and check which of them work for the second equation. That is x minus 3 square is equal to 4. Or I can solve this equation first, get the two solutions and check them in the absolute value equation. Either way is fine. So I'll solve the second equation first. X minus 3 square is 4. So if a number squares 4, then that number must be, well, suppose y square is 4. Then y can be either 2 or y can be minus 2. Because both these numbers squared give 4. So I know there are two solutions. In this case, x minus 3 is squared. So therefore x minus 3 must be 2 or x minus 3 must be minus 2. I solve both. In the first case, I get x is 5. In the second case, I get x is minus 1. So these are my two solutions for this equation, for the square equation. Since these two solutions have to be now tried in the absolute value equation, I'll just plug them in. So I'll plug in 5. I'll get 2 into 5 minus 4, which is 10 minus 4. Which is equal to 6, not equal to 2. So 5 is not a solution. So I'll plug in minus 1. I'll plug in 1. X minus 3 is equal to minus 2. X is equal to 1. So I'll plug in 1. 2 into 1 minus 4, which is 2 minus 4. Absolute value of minus 2 is 2. That works. The right hand side is 2. So plugging in 1 worked. So the solution is 1, A. So there are many ways to approach this. Solve any one of those equations, try out those solutions in the other equation and see when both equations are satisfied. Of course, the third way would be to just plug in each value in both equations, and if that value satisfies both equations, you're done. That would turn out to be the quickest method in this case. If I plug in 1 in the first equation, I get 2 minus 4, that's minus 2, absolute value of minus 2 is 2. And if I plug in 1 in the second equation, I get 1 minus 3 whole square, which is minus 2 square, which is also 4. So both equations are satisfied. Solve for x. Absolute value of x is equal to minus 2x minus 6. Let's understand how do we solve such equations when there are x's on both sides of the equation. So the absolute value of x, its answer depends on x. If x is positive, then the absolute value of x stays x. Then absolute value of x is x itself. For instance, absolute value of 4 is 4. But if x is negative, then the absolute value of x does not stay x. It becomes the negative of x because you want a positive answer. So the absolute value of x becomes negative x. For instance, if x is minus 4, then the absolute value of x is not minus 4. It's the negative of minus 4 because you want 4. So the absolute value of x is negative x when x is negative, and the absolute value of x is x when x is positive. So I'm going to do two cases here. I'm going to assume x is positive or 0. X is greater than or equal to 0. Then I know that absolute value of x is just x. The absolute value of a positive number is itself. So I'm going to use x for absolute value of x. So the equation becomes x is equal to minus 2x minus 6. And this I can solve. I take the minus 2x on the left, I get 3x is equal to minus 6, which implies x is minus 2. So do I have a solution? There's a problem. What have I assumed on x? I've assumed that x is greater than 0 and I've got x is minus 2. Minus 2 is not greater than 0. So this value of x is invalid. It contradicts my assumption. So this is not a solution. So when x is greater than 0, there are no solutions. So next I'll assume x less than 0. Now if I'm assuming x less than 0, then the absolute value of x is negative x. So this is what I'll use in the equation. So the equation becomes negative x is equal to minus 2x minus 6. And I can solve for this. Take the minus 2x on the other side, it will become x is equal to minus 6. Fine. Now it looks reasonable because when x is minus 6, x is less than 0. I have not contradicted my assumption. So x equal to minus 6 is a reasonable solution. It is a valid solution. So my only solution is C, x equal to minus 6. What's the best way to confirm this? Plug it in. So let's plug in minus 6. I get modulus, I get absolute value of minus 6, which is 6. That's the left hand side. And the right hand side becomes minus 2 into minus 6, which is 12 minus 6, which is also 6. So the right hand side is also 6. So minus 6 works. The left hand side and the right hand side turn out to be equal. So our solution is minus 6. Of course, the best way to do this question would have been to just plug in each value in turn and see which one works. But I wanted to emphasize the nature of absolute value of x. Absolute value of x is equal to x if x is greater than or equal to 0. And absolute value of x is equal to minus x when x is less than 0. Solve for x. Absolute value of x plus 2 is equal to x minus 6. So here we'll try by plugging in values. Let's try a. So I plug in a on the left hand side and on the right hand side. When I plug in minus 2, I get minus 2 plus 2, which is absolute value of 0, which is 0. On the right hand side, I surely do not get 0, I get minus 8. So a is not the solution. B, I plug in 2. 2 plus 2, absolute value of 4 is 4. On the right hand side, 2 minus 6, get minus 4. 4 is not equal to minus 4. C, I plug in minus 4. Then minus 4 plus 2, which is the absolute value of minus 2, which is 2. And on the right hand side, I plug in minus 4 minus 6, I get minus 10. Again, minus 10 is not equal to 2, so C is out. How about D? All real numbers? Well, obviously not, because here are 3 numbers which are not solutions. So D cannot be the solution. The only choice left is E. No solution. Since I've eliminated A to D, the answer must be E. How would you prove this? How would you show there's no solution? Well, you do what we did in the previous question. You take a range of values for x and break it up into 2 equations, and you'll show that each equation leads to invalid results. So finally, there are no values of x that work. So there are no solutions. Rational equations. Recall that a rational number was a number of the form a by b. Both a and b were integers. And of course, b was not allowed to be 0 because we can't divide by 0. So for example, 2 by 7 is a rational number. Minus 3 over minus 9 is a rational number. 4 over minus 11 is a rational number. So what are rational equations? So what are rational expressions? Rational expressions. We also saw in a previous lesson that rational expressions are polynomials upon polynomials. So something like x square minus 3 over x4 plus 4 is a rational expression. So a rational equation will be something which involves rational expressions and an equal to sign because you want to make an equation out of it. So something like 1 over x minus 2 equal to 3 would be a rational equation. Anything that involves a rational expression and an equal to sign and some numbers would give us an equation. Solve for k. 3 upon k plus 1 over 2k is equal to 1. So I have 3 over k plus 1 over 2k equal to 1. So what do I do when I have two such fractions? Well, I take the LCM. So what's the LCM of k and 2k? It's 2k. So my LCM is 2k. I get 3 into 2 plus 1 is equal to 1. So I get 6 plus 1, 7 over 2k is equal to 1. So I cross multiply, I get 7 over 1 is equal to 2k. That is 7 is equal to 2k. So dividing both sides by 2, I get 7 over 2 is equal to k. 7 over 2 in my answer choices is E, 3.5. What's a quick way to confirm this? Plug it in and calculate it. Solve for t. 5t over t plus 1 plus t over 3t plus 3 is equal to minus 56 over 6t plus 6. So here we have rational expressions on both sides of the equation. But anyway, the first thing you do when you need to add such expressions is find the LCM. So what's the LCM of t plus 1, 3t plus 3 and 6t plus 6? The quick ones will notice that 3t plus 3 can be factored as 3 into t plus 1 and 6t plus 6 can be factored as 6 into t plus 1. So our LCM of t plus 1, 3 into t plus 1 and 6 into t plus 1 is 6 into t plus 1. That's the LCM. All three expressions divide 6 into t plus 1. So that's my LCM. 6 into t plus 1. So the left hand side becomes 6 into 5t plus 2 into t. And the right hand side stays as it is because it is 6 into t plus 1. Let's simplify the numerator. 6 into 5 is 30. 30t plus 2t. 6 into t plus 1. Minus 56. 6 into t plus 1. So I get 32t is equal to minus 56. Of course, there's a denominator which is the same. Can I solve this now? Can I cancel the denominators? Well, firstly, for these expressions to make sense at all, the denominators can't be 0. So 6 into t plus 1 had better not be 0. That means t plus 1 had better not be 0. That means t cannot have been minus 1. So we are working under this assumption that t is not minus 1. If t is minus 1, nothing makes sense. Now let's solve it. If t is not equal to minus 1, then 6 into t plus 1 is not 0. So I can cancel out 6 into t plus 1 on both sides. And what I'm left with is a very simple linear equation. 32t is equal to minus 56. Dividing out, I get t is minus 56 over 32. Minus 14 over 8. or rather minus 7 over 4. Now this solution minus 7 over 4 is valid because it's not equal to minus 1. So it's a valid solution. Solve for y. 1 over y minus 3 minus 1 over y is equal to 1. So again I need to take the LCM, but the LCM of y minus 3 and y is just the product. They have no factors in common. The LCM is y into y minus 3. And the numerator becomes y minus 3. This whole thing is equal to 1. So I simplify the numerator, it becomes y minus y plus 3. I'm distributing the minus 1 across the y minus 3. We've seen that in an earlier lesson. Upon y into y minus 3. So this becomes 3 over y into y minus 3 because it's equal to 1. So what are the assumptions we're working with here? The denominators can never be 0. So y minus 3 cannot be 0. That means y cannot be 3. And the second denominator is y. So y cannot be 0 either. So y cannot be 0 or 3. These two values are not allowed. So if I get any of these two values in the solution, that's invalid. Okay, let's get back to solving this. I cross multiply, I get 3 is equal to y into y minus 3. If I open out this, I get y square minus 3y. So I have a quadratic equation. I get y square minus 3y minus 3 is equal to 0. So I need a product of minus 3 and a sum of minus 3. That's never going to happen. I'm never going to be able to find nice numbers whose product is minus 3 and whose sum is minus 3. So what's the method of solving this quadratic? I have to use the quadratic formula. The solutions are minus b plus or minus root of b square minus 4ac over 2a. Plug them in. Here a is 1, b is minus 3 and c is minus 3. So my solutions for y are minus of minus 3 plus or minus root of minus 3 square minus 4 into 1 into minus 3 over 2a, which is 2. So that's 3 plus or minus root of 9 plus 12 over 2. Let's go back here. So it's 3 plus or minus root 21 over 2. Sorry, 2. And those are my two solutions. 3 plus root 21 over 2 and 3 minus root 21 over 2. So those are the two solutions for y. If x minus 4 upon y minus 3 is 0, which of the following must be true? X minus 4 over y minus 3 is equal to 0. Well, what's the first thing I can say when I see a rational expression? The denominator can't be 0. So I have to say y minus 3 cannot be 0. So the denominator can't be 0, which means y cannot equal 3. I can cross multiply. I can get x minus 4 is 0 into y minus 3, which means it's 0. So I get x minus 4 is 0, which means x is equal to 4. So I need to get x equal to 4 and y not equal to 3 to have this expression equal 0. That's my complete solution. C. Solve for x. 1 over x plus 1 minus 3 over x minus 1 equal to 2 over x square minus 1. Again, all the action is in the denominators. We need to add two rational expressions. So let's study the denominators. X plus 1, x minus 1, x square minus 1. I need the LCM. Well, I know that x square minus 1 is x plus 1 into x minus 1. And that's just wonderful. Because now the LCM of all these three expressions is x square minus 1. Because each of these is a factor of x square minus 1. So my LCM is x square minus 1. Let's add. So 1 over x plus 1 will become x minus 1 over x square minus 1. If you don't see the step, let me show it to you carefully. So I'll start with 1 over x plus 1 and I'll multiply the numerator and the denominator by x minus 1. So it becomes x minus 1 over x plus 1 into x minus 1, which is x square minus 1. Similarly, 3 over x minus 1 will become 3 into x plus 1 over x square minus 1. I have multiplied numerator and denominator by x plus 1 in this case. And the right hand side will stay itself because the denominator is already the LCM. So the entire expression becomes x minus 1 over x square minus 1 minus 3 into x plus 1 into x square minus 1 to 2 over x square minus 1. Since the denominators are same, we can directly subtract. So square minus 1. I get x minus 1 minus 3x minus 3. On the right side, I get 2. So let me set up the equation again. I get x minus 1 minus 3x, that's minus 2x, minus 1 minus 3, that's minus 4, equal to 2 with common denominators. Now what do I assume? Well, I can't have the denominator ever being 0, so I will have to assume that x cannot equal 1 and x cannot equal minus 1. These two are forbidden values because they will force the denominator to be 0. Now that I've assumed this, I can cancel out the denominators and I get minus 2x minus 4 is equal to 2. So I get minus 2x is equal to 6 and I get x is equal to minus 3. That's my solution. C. So nice question. The denominators were related because x plus 1 into x minus 1 is equal to x square minus 1. Once you notice that, everything falls into place. Notice that my solution minus 3 is not 1 or minus 1. So it's a valid solution. That's very important to check in the end that the solutions you get are valid. They don't contradict your assumption. 2 over x minus 3 minus 3 over x plus 3 is equal to 12 over x square minus 9. Again, I notice that x minus 3 into x plus 3 is x square minus 9. So it's a similar kind of question. The LCM of the denominators is x square minus 9. So 2 over x minus 3 can be written as 2 into x plus 3 into x minus 3 x plus 3, which is 2 into x plus 3 over x square minus 9. Similarly, 3 over x plus 3 can be written as 3 into x minus 3 over x square minus 9. I'll leave the steps to you. So the left hand side becomes 2 into x plus 3 over x square minus 9 minus 3 into x minus 3 over x square minus 9. And the right hand side stays 12 over x square minus 9. Let's simplify this numerator. Becomes 2x plus 6 minus 3x minus 9 equal to 12. So this becomes 2x minus 3x will be minus x. 6 plus 9 will be 15. So I get minus x plus 15 is equal to 12. So I get minus x is equal to minus 3, x is equal to 3. I'm getting a solution x is equal to 3. Is this okay? This certainly isn't okay because this is an invalid solution. I'm not allowed to take x equal to 3 because my assumption is that x is not equal to 3 or minus 3. The denominators cannot be 0. So my solution x equal to 3 is invalid. And there are no solutions. All the answer choices are wrong. Ignore them. There are no solutions to this equation. Solve for t. T minus 2 over t plus 7 is equal to 1 over t minus 1. Well, look at the answers and try plugging them in and solving. That's one way. The other way is to actually work through the equation. Let's work through the equation. So what's the LCM of t plus 7 and t minus 1? Unfortunately, it's just the product. They have nothing in common. So the LCM is t plus 7 into t minus 1. And what are our limitations on t? Well, neither of these can be 0. So t cannot be minus 7 and t cannot be 1. Because these two values will make the denominators 0. Look at these two values. I immediately eliminate this choice and I eliminate this choice. These two choices and this choice. Three choices are gone. So now it's easy. I only have two choices to pick from, C and E. So I can now plug in and try. I won't plug in 5 because 5 is common to both. So I know 5 will work. So I'll plug in either -1 or 7. Let me plug in 7. So the left hand side, plugging in 7 becomes 7 minus 2 over 7 plus 7. That's 5 over 14. And the right hand side becomes 1 over 7 minus 1, which is 1 over 6. These two are not equal. So I know my answer is C. I know my answer has to be C. Let's plug in -1. If I plug in -1, I get -1 minus 2 over -1 plus 7. That's -3 over 6. That's minus half for the left hand side. And if I plug it into the right hand side, I get 1 over -1 minus 1, which is minus half for the right hand side. So left hand side equal to right hand side. Let's just plug in 5 for the heck of it. 5 minus 2 over 5 plus 7. That's 3 over 12. That's 1/4. And right hand side, 1 over 5 minus 1 equal to 1/4. Yep, confirmed. So the answer is C.